So, what is special about BGP is the tuning. You can tune BGP to have a very nice, precise, policy based path selection for packet forwarding. The other protocols are not this flexible like BGP. You do have an option to tune as per your policy by using um, route maps, but they are not up to the mark. I can say they are not. With other protocol, it is not easy. You need to do a lot of works to achieve simple things. Whereas in BGP, just by giving one command, you can do a lot of things. So BGP is more flexible to have a path as per the policy. The selecting of BGP path is using attributes. So if you know how the attributes behave, you will be effectively using it. So the attribute makes the tuning easier. We need to understand each attribute. When you understand, we will know which attribute suits our policy in path selection. That's the main theme of today's class, understanding attributes. See, if you know only how to enable BGP, it's not knowing BGP. You should know attributes of BGP thoroughly. Only then we will be able to use it. We'll be able to use BGP properly. If not, BGP will become a burden. BGP, by default, it is going to consume a lot of processor. And if you don't use the protocol properly, then if you are going to use BGP like other routing protocol, if you are going to use BGP like other routing protocol, simply like just for routing sake, distribution of routes, then we are not using BGP effectively. Meaning, it's waste of BGP. You should have used the other protocol. If you don't know how to use the attributes of BGP, and if you'll simply use it as another routing protocol, it's a waste of processor. You should not go for BGP. So one should know the attributes very well. Only then he can use it effectively. This chapter and the following chapters are about understanding this attribute. So according to me, what we learn today, tomorrow is what more important in BGP. And also the third day following the year, we'll be able to finish in these 3 sessions. So let us now get into it. BGP metrics are also called as path attributes. Characteristics of path attributes include well-known, sometimes optional, sometimes mandatory, sometimes discretionary, sometimes transitive, some are non-transitive, and sometimes attributes will be partially applied. So let's see what it is. Well-known versus optional, meaning there are some attributes of BGP which is well known to every vendor, every BGP appliance. Say for example, human. Human well-known attribute is he can speak, he can reason. That's well-known attribute. But human's optional attribute is to protect himself or herself. They can kill others. optional. It's not well known. Human beings are not known as a killer, but they can also do that for some reasons. Maybe good reason, bad reason, I don't know. But killing is bad, right? Anyway, well known optional, mandatory discretionary, transitive, non transitive. Like we human beings have got various attributes. Some attributes are well known, some are mandatory as a human being, some attributes are mandatory. Should speak truth. It's mandatory. Otherwise, there is no difference between animal and man. Speaking truth is the real characteristic, the real attribute the man should have. If he's a real man, why should he cover things? Then he is not a real man, he is fake. When he say a lie, he is no more human. He has lost his dignity. So it's a mandatory, not only well known, speaking truth is not only a well known attribute, it is mandatory. It's mandatory. Otherwise, he is no more a human. Whoever he may be, when he say lie, he's dead. He's dead. He may be alive physically, but he's dead. Likewise, there are some attributes which is removed from BGP. It's no more BGP. Psh, finished. Not possible to be called as BGP. It will be always seen with BGP. Such attributes are well known as well as mandatory. Of course, all the mandatory attributes are well known only. All the mandatory attributes should be well known. Some attributes are discretionary. May be present, may not be present. That is discretionary. Discretionary. Some are optional. That is also kind of maybe present, may not be present, but there's a connection between the optional and transitive and non-transitive. So more detail is coming in the next slide. Look at this. Well-known attribute means what? This attribute must be recognized on all BGP compliants, all BGP devices. And these attributes are propagated along with the network advertisement. When the network is advertised, the attribute of that network is also advertised to other neighbor. Such attributes are called as well-known. For example, there is an attribute called next hop. Next hop is a well-known attribute. Next hop. See, when someone is advertising your route, if they don't put any next hop in it, what is the use of that route advertisement? There is no use of processing the route for you. You don't have any clue where to send now. Someone says, yeah, there is one man who can give you a solution. What one man? There are many men there in the world. There is one man who can provide you the solution. You should tell exactly the name. Which man? So, or where he lives. So well known is an attribute which is known to every BGP appliance. I gave you an example. Next hop. This network, if you want to reach, this is the next hop. That next hop is a well-known attribute. It's a well-known attribute. Now, in that well-known attribute, you have mandatory attribute and you have discretionary attribute. The mandatory attributes must be seen there on every update messages. must be seen. Example, I already said next hop is one example. Well-known mandatory. Well-known mandatory. It's well-known meaning it's known to every BGP appliance. Not only that, it must be seen on every BGP update. If not, that update is rejected. Such attributes that must be seen and known to everyone is what well-known mandatory means. Now, what is well-known discretionary? It is well-known only, but may be present, may not be present. For example, there is an attribute called MAD, multi-exit discriminator, MED. This attribute, if it is set, it is going to be. If it is not set, nothing. Our local preference is also well-known discretionary. You know why? Local preference is a numerical value that is advertised only between IBGP neighbor. With eBGP, they don't advertise. So, well-known discretionary attribute may be present. See, it is well-known only. Everyone knows that there is an attribute called a local preference. But it is not mandatory to be seen. It is not mandatory to be seen. Next is optional. Optional attributes are recognized by some BGP appliance. They are recognized by some implementation. This could be a private attribute, but executed not to recognized by all, but expected not to be recognized by all BGP routers. So this may also sound like discretionary, may be present, may not be present, but I told you this is connected to transitive and non-transitive attribute. That's what the differences see here. Optional attributes are not expected to be seen on all BGP appliance. Recognized optional attributes are propagated to other neighbors based on their meaning. Meaning, if I see an an update, in that I am seeing one optional attribute. Now, based on the meaning, I'll decide whether to propagate it or not to propagate it. What does that mean by meaning? Here is the description, the 2 points below. Optional transitive means one thing, optional non-transitive means another thing. Meaning, when I receive an update, if the optional attribute is not recognized, if it is not seen, I still accept that update. See, that's the meaning. You can still accept the update, but you need to mark the update as partial. Hope you got the meaning why they put partial at the last after transitive, non-transitive. So in transitive, you are expecting some optional attribute in the update. If it is seen, you use it. If it is not seen, you just mark the update as partial, so that if there is another update from someone with the optional, you can prefer that and ignore this. That's why you mark it as partial. If not recognized, mark as partial and propagate to other neighbor. Such attributes or optional transitive attribute. Let me repeat, optional transitive attribute, if not recognized, they are marked partial and propagated to other neighbor. Optional non-transitive attributes, they are discarded if not recognized. See, optional attribute only, but sorry, yeah, I'm repeating. Okay, optional transitive is an attribute that may be present. If it is present, it is considered as complete update. If it is not present, it is considered as partial. Example, optional transitive is like, let's say Cisco is sending an update to BGP update to another vendor router. That another vendor router expects one particular attribute which is actually local to that vendor. Anyway, Cisco is not going to know about that optional attribute, about that vendor's optional attribute. Cisco routers are going to send the update. But when the update is received by the other vendor device, if the other vendor device still accepts the packet, then it is optional transitive. If it says, no, 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 I want to see the attribute, otherwise I will ignore, then it is optional non-transitive. So this optional transitive and optional non-transitive will come only between the vendors. Some vendors will have their own attributes. So between their routers, those attributes will be shared. And if the other vendors don't share the update, that attribute in the update, if this is going to ignore it, then it is called as non-transitive. Optional non-transitive. Though it is optional, but still, I'm not going to entertain till I see it. That is optional. No. I know this is what everyone will say as example. No. First of all, weight is locally significant to the router. Even even in Cisco, even inside Cisco's domain, weight that you configure on one router is not going to be going to another Cisco router. Sometimes in flow people talk weight as an optional, all those things, but again, that is their misunderstanding. Weight is local to the router. That is always non-transitive only. Sorry, I should not use the word non-transitive here. That is always local to the router. It is not sent along with the route update. It is not sent along with the route update. Yep. So weight is not an example for this. Anything else you have in? So don't take weight. Weight is not the right example. Now we have a lot of attributes in which these are the attributes that are going to be tuned by us. We have many attributes. We have around 13 attributes. But all those things are not under our control. These are the things that you can tune. But we'll be seeing all the attributes, but before that we'll finish this. This needs more explanation and deep dive than the other. AS path means what? When a route is advertised from one BGP autonomous system to another autonomous system. The advertising autonomous system will put its autonomous system number and forward the update to next autonomous system. So when next autonomous system receives the update, route update, it will also see the autonomous system from where it comes. That's why BGP is called as path vector routing protocol. It shows the autonomous system path through which the route is advertised, carried. The advertisement is carried. AS path is a attribute which is well known to everyone. See, BGP by name itself is path vector routing protocol. BGP is a path vector, so you cannot remove AS attribute, AS path attribute from BGP. BGP means always it will have AS path information in every updates. So path vector, AS path is one of the attribute which will be always seen, whether it is between one vendor to a different vendor or between the same vendor router, within IBGP environment or between EBGP. Anywhere you sniff a packet and see BGP's update packet, you will always see this AS path. Next hop is also another example for well-known and mandatory, always seen. Origin is also always seen. Let's say there is one router in Chicago, another router in Melbourne. Now, the router in Chicago will clearly tell you how this network originated. The router in Chicago will very clearly tell that in Melbourne, someone used the network command and advertised this network. And it will show how it originated, how it is introduced, how this network is injected in Melbourne. There are two ways in injecting route. One, redistribute. The other one, advertise. That is what origin, how it is originated, how it is introduced, how it is injected. So the router in Chicago will clearly tell you how it is injected inside. If it is injected through redistribution, it will have a question mark called incomplete. If it is injected using network command, we call it as advertisement. If it is advertised in BGP, if a network is advertised in Melbourne via BGP, then it will have I. I here says BGP's internal network. It is not saying IBGP or EBGP, it is saying how it is introduced. If it is I, means our own, BGP's own. If it is redistributed, definitely it is coming from some other protocol into BGP. So it is external, meaning incomplete. It's not BGP's own.
The route update will have question mark. Is it?
Yeah, correct.
Question mark means
It is redistributed into BGP from somewhere. So this is also a mandatory, well known. As I said, all mandatories are well known. So well known mandatory attributes, example, AS path, next hop, origin. Local preference is well known but not mandatory. Well known, but between the EBGP neighbors, local preference will not be advertised. Local preference is only for those routers within the autonomous system. Right. Next, MED is also well known but not mandatory. MED is also known to every vendor, but MED comes only in a scenario where you have dual homing. Dual homing. More than one connection to same ISP is dual homing. Multiple connections to different ISPs is multi-homing. Here is an example for AS path. Kindly read by yourself once, and then if you have a question, let me know. The sequence in which the AS numbers are arranged in the update is the first one is the immediate AS, means the next AS. The last one is the AS from where it originated. See?
For position 1.0, so it put its own AS first and the destination AS.
No. See. This is the network that is advertised. While advertising, B will say, I have a network. I'm just writing, in short 2.0. I have a network called 2.0, and this is originating from 6500. Now, this C receives it, and when C propagates it, it will say, I'm giving you 2.0. I am 65500. I received it from 6500. That is how C will advertise to A. And now, when A pings B, it will go to 6500 first, and then from there it will go to 65500, and then from there it will go to 6500. Now I just given you the 2.0 as an example. Here they have given you 1.0 as an example. You need to see the other way around. Okay. So when you receive an update, whatever you see first is what the immediate autonomous system number, and the following is what the next immediate, meaning the last one is the one from where it originated. Let me show you an example. This is the place where this network originated, and from this autonomous system it is received.
What if this router is also part of 64999, this AS?
It won't show. It will show.
Then does it show only 64997?
Yes. For example, this network is coming from 64998, which is the immediate autonomous system. This router's autonomous system is not displayed here, so I'm not able to show you that, but that is the truth. So you will not see your own. Let me go back and you see, B is in 6500. Do you see 6500 here in the list?
No, it's okay. This 6 5 6 double 5 double.
Always the very first one is the EBGP, immediate EBGP, the first one.
Okay, but as you said, AS is a well-known attribute.
Well-known mandatory.
It's mandatory.
Yes.
Mandatory in the update.
Yeah.
But we are not seeing
What? It is seen now. See, it should show the.
Sorry, it is other way. No, I got it. Because he talked about it on other way and all. Yeah. Sorry, my mistake.
All right. Now, this is next hop attribute. Always the next hop address is advertised. And we also know the next hop behavior. Inside IBGP, the EBGP's address is carried. For example, about this 172.16.0.0, when B advertises to C, it keeps 10.10.10.3, which is of A. B is not putting its own address. Right. So next up is also well known and mandatory. Kindly go through this example once and let me know if you have a question. Wonderful. So let's move to the next one. See, the origin attribute is, as I said earlier, it shows how this network is injected. Once upon a time, there was a protocol called EGP. Like BGP, you had a protocol called EGP. So when a route is given by BGP, high preference is given, and when a route is given by EGP, next preference is given, and for the redistribution, the last preference. So 3 level of preference. First preference is for the BGP router giving me, because I am also BGP. Second preference is if BGP routers are not giving, I'll receive from EGP router. EGP was one old protocol. If EGP and BGP gives me, I prefer BGP and I ignore EGP. But what if they both don't give? Both IGP and EGP means BGP is not giving me. That's what IGP here means. Here, IGP is not interior gateway protocol. Here it means internal network. Internal network. IGP is internal network.
Yes. Could you show me that? We have shown a router diagrams in the routes.
And if you see here, sorry, carry on. Yes.
So when it says I, so these are advertised.
Correct.
It's actually originated from 64997.
And in that autonomous system, there is some router. There is one router where this network is advertised. It is advertised to neighbor, whichever the next neighbor is. It is advertised to a router which is peering with 64997. It is advertised to a router in 64998, which is pairing with 64997.
And also to this router A as well.
Of course, but router A knows its own autonomous system. It need not to be there in the list. Again, who advertised to router A? It is not 64997, it is 64998 advertising to E. Okay, so if you don't see I, you will see question mark, which means in that autonomous system 64997, maybe from OSPF or from static root, they might have redistributed into BGP. You will never see this E anywhere because this is no more a protocol anywhere. No one supports it. Cisco don't support a protocol called EGP. So you won't see that E anyway. But which is preferred? Is I preferred or question mark preferred? I is preferred. I, origin code I is preferred over question mark. Smaller is preferred. I is smaller. Smaller is preferred. I is smaller than E. E is smaller than question mark. Smaller is preferred. The origin attribute informs all the autonomous system in the internet network. That's why I said in Melbourne you advertised using network command. In Sydney, in Chicago, you can see it very well. All the autonomous system will be informed about how the prefix got introduced into BGP. So origin attribute is also a well-known and mandatory attribute. Right, so this is output we always use. This is a command we always use to see the attributes that are attached and advertised along with the prefixes to us. To router A, all these networks are advertised with all these attributes. You can see next stop attribute, you can see metric. This metric is nothing but MED, multi-exit discriminator, which is well known, not mandatory, well known. Local preference, weight, AS path, origin. So all attributes are seen here. These are the attributes actually. These are the attributes that is tunable. That's why you don't have 13 attributes in the list. Only these attributes you see because they are the one which you see here also in this table, in this output. These are the tunable one, right? Yeah. Local preference is another attribute. See, this attribute is local to the autonomous system. You need to understand this very well. You see, there is a number called local preference that we have as an attribute. This number, if it is bigger, more preferred. In this autonomous system 65350, we are learning about this network via B as well as via A. A is also advertising that network, B is also advertising that network. Now, if you wish all the other routers in the autonomous system, you've got many routers. If you wish all the routers in the autonomous system to go via A, if you want to go via A, you want to exit via A, then you need to set the local preference higher and all other routers will know that A is having higher number. How? This attribute will be advertised to all the routers. You set it on A will advertise to C, D. So D and C will know that if I go via B, preference is only 150. If I go via A, the preference is higher, higher is preferred.
So local preference value is transitive.
Only within the autonomous system. Only within the autonomous system. So this 150 will not be advertised to this router here. Whatever you configured in B, it will go to D and C and A also. Whatever you configure in A, it will go to C, D and B. Whatever you configure in A will not go to K router. Will not go to K router. So here the arrow mark in the picture, what it shows is the path taken. All will go via this way out because this has got a high local preference. See, BGP with the highest local preference values are preferred. Local preference is used to advertise to IBGP neighbor about how to leave this autonomous system. If the number is big, that is the router you should leave this autonomous system. Local preference is sent to IBGP neighbors only. The local preference attribute is a well-known as well as discretionary, meaning it may be present, may not be present. As I told you, between EBGP will not be present. Within IBGP environment, this will be present. That's why it's discretionary. It is
Consider this as partial.
the word partial will come only when optional attribute is not present and transitive. This is not an optional attribute. This is well known. Optional attributes are not well known. Some vendors will have it, some vendors will not have it. That's why optional, when you ask me example, I was not able to give you a name for the attribute because it varies from vendor to vendor. Optional is it's not well known. Optional is popular. It's according to BGP attribute, the opposite of well known is optional. In this place. Okay. So discretionary sounds like optional, but it is not optional. See, discretionary is the word given to an optional, which is a well-known attribute. Discretionary word is given to the attribute which is well-known at the same time may be present, meaning optional. So instead of calling it as an optional, we call it as discretionary. The default value of local preference is 100. Next is MAD. MAD is another attribute which is used whenever you have dual homing. If you see A has got two connections to upstream B and C, which is in same autonomous system. B and C are in same autonomous system. So we call connection from A as dual home. A is having dual home to B and C. Dual home. Now whenever you have dual home, those dual, that upstream, the one on the top, can decide via which A can enter. Listen, B and C can decide. Means 65500 can decide via which A will enter in to reach 172.20.
Jay, could you come that again? And could you tell me
When you set
the ISP and
now ISP can decide to reach this network, A will use B or C. If ISP wants B to be the gate for A, the primary gate, then MAD should be lower. MAD should be lower. Lower is preferred. So A will choose B as the gateway to reach this network, not C.
Jay, so we configure MAD values 115 to
Only on B and C, not on A.
because it is non-transitive. How does A know which is the MAD value?
You forgot the meaning of non-transitive. You forgot the meaning of non-transitive. See, optional attribute, if it is not seen, even though it is not seen, if you will
Not seen in the update, right?
even though it is not seen in the update, if you will still consider as an update partial, then it is optional transitive. It is optional transitive. Here, transitive not talking about any distribution of route. It's a name given. It's called optional transitive, meaning I still consider this update. I'm going to use the update. I may transit it, I may not transit, depends on how many neighbors I have. But I'm ready to use the update even though it is not found. I'm ready to use considering it as partial. Non-transitive is if it is not found, I'm not going to use it. See, that is why if you see the output, at least you will have 0 because it should be seen. Right? It is optional, but if it is not found, I'm not going to forward the packet. I'm not going to forward the packet if MED is not found. At least 0 should be there. And MED is only between EBGP neighbor. That's why you don't see MED for some neighbors because they are IBGP neighbors. When we do this, you will understand it more clearly.
I agree about this.
All right. I'll try to put it in your own words. I'll try to give you better explanation. Ask your question in where you don't understand.
Again, I'm sorry. On C, it's configured MAD value as 200. On B, it is 150. So you said the lower is preferred, right?
Yeah, lower is preferred.
Lower is preferred.
Why?
But the value, B knows about the value and C knows about this value.
A will also know it. No, who said A doesn't? A will know about it.
But this value will not be propagated to B.
No, it will be propagated to A. I told you it will be advertised to the EBGP neighbor.
Okay, so A will not advertise again.
No. It won't advertise to anyone else. It's only for.
Okay.
Yeah. Yeah. So.
Okay, so A will keep the update.
And A will use it for sending the packet.
Packet to B or C, but A will not advertise to any other, let's say there is another
It won't. It won't.
router connected from. Okay.
Okay.
So I always used to wonder if I configure the attributes on my router, on my interface, and it is not sensitive, how does the other router know what value I have? So this was the condition. Now I get it.
Okay. It is sent. That's why I don't literally take the word non-transitive. It is sent to eBGP neighbor. All right. It is sent to eBGP neighbor. At least 0 should be there to use this attribute, but not between IBGP, only eBGP. We'll